All right. Hi, everyone. I'm Jaana, and I came here to talk about what is going on with OpenTracing and OpenCensus. So I used to work for OpenCensus as one of the co-leads, and I just decided to kind of like move to a different project. And this is my like retirement from observability, actually. After this talk, I'm retiring. And I thought it might be a good time to come here and do some introspection. If you are not familiar with these projects, they are both instrumentation projects. OpenTracing is more scope to tracing. OpenCensus is a more holistic instrumentation library that covers more bases than just tracing. But the overall goals are somewhat similar, at least in the scope of tracing. So we all know the story of the tip of the iceberg, right? This is your application as seen as your users, and this is also what they experience. But the reality of your system is quite a little bit more complicated. You, as a developer, probably have like more of sense of what is going on in terms of like the components and whatever is actually making up the entire system. This type of visibility is either available to you because you can read the source code, the documentation, the configuration, or by some dynamic tools. And this is where the observability comes into place. One of the definitions of, I think, observability is about how well you can understand the system by telemetry that is coming out of that system. And when we say telemetry, we usually say like, all these different signals, traces, metrics, logs, or whatever. And all these signals that can get out of the black box is determining the level of visibility you can achieve. Both OpenTracing and OpenCensus had these projects were targeting the same goal. They wanted to provide more visibility to black boxes where we actually have like critical telemetry coming out of infrastructure and your systems as well. Since we started OpenCensus, this is like I've been to pretty much everywhere on the planet, and this is the the recurring question that was coming to me. So these projects look really similar, but what is the difference between OpenTracing and OpenCensus? And even if they're not the same project, why OpenCensus is actually not OpenTracing compatible? Because one of the promises of OpenTracing is like, hey, let's have some sort of like a common standard, common base for distributed tracing. So why did OpenCensus ended up like going in a different direction and is not really OpenTracing compatible? As I said earlier, we have these two different projects. They are somewhat similar. Some people might even think that they are identical, but there are actually lots of differences between them. Let's go through like some of the actual like similarities first. Well, the first one is actually a difference. So OpenTracing, as I said, is just only focusing on tracing. Whereas OpenCensus is covering more verticals. It actually cares about like correlation between different signals and so on. Right now it's supporting tracing and metrics, but we may actually include logs to this list. OpenTracing is trying to be an API. So it's only just like think about OpenTracing as a header file. It's entirely up to the vendor to provide the implementation. And all the implementation details is what OpenTracing just doesn't actually care about. It provides some flexibility, but at the same time, it's just like is a lot of work for the vendor. OpenCensus, on the other hand, is providing an actual instrumentation implementation. And it's not just an API, it's just the entire instrumentation library. There is some data collection infrastructure, there are some agents, some collectors, and this entire ecosystem and some data formats. OpenTracing provides this like more of like a looser coupling because it's tiny and small scope and it's just tracing. On the other hand, OpenCensus is a really wide API as well as the implementation itself. So it's a little bit like tight. OpenTracing has more support for languages at this point. OpenCensus came around just briefly like 1.5 years ago, and we have 5 in beta. And just because we've been playing and still trying to figure out the APIs, although we were not breaking anything critical, things ended up being in beta for a while. They both have like some sort of broad adoption. I think the two, as I said, we have these differences, but then we realized that these two projects have really critical issues. The first one is OpenTracing only has tracing in it. And users usually want to, when they're instrumenting, they want more than tracing. And they don't like to pull, multiple dependencies. They don't want to like switch to a entirely different instrumentation library to do, support other signals. On the other hand, OpenCensus kind of is just like this really opinionated, big, instrumentation library, and it doesn't give people a lot of flexibility. It's just like you get this like big library, and it's really opinionated in terms of implementation. And OpenTracing is providing quite a little bit like of a flexible model, but it's, as I said, it's definitely not opinionated on implementation. It's not opinionated on performance because it entirely depends on the implementer. You as a vendor want to provide an OpenTracing, support, and you go and implement the entire API surface. So it's up to you, how you're actually going to do performance optimizations and so on. OpenTracing is also doesn't care about the propagation formats. So there's like nothing by default, and again, the vendor is supposed to pick the right propagation format and need to implement it as a part of the implementation. And OpenTracing doesn't actually define and export data, so there's no intermediate data. It's again like every vendor's responsibility to export their own data coming from the instrumentation. On the other hand, OpenCensus is the exact opposite. It's really opinionated on the implementation. We also wanted to make sure that like we are opinionated on the implementation, so actually we have some opinion on performance as well. If you switch to a different vendor, we don't want to give you a different performance. Like just imagine that if everything is so flexible and implemented by vendors from scratch, each time you change your vendor, you may actually end up like having different performance characteristics coming from your system. And OpenCensus, even though it is providing some flexibility in terms of propagation formats, it's actually providing a default propagation format. And OpenCensus is actually more about the export data. We have this intermediate data format, which is the OpenCensus data format, and you can just take it and convert it to whatever vendor-specific format, but we actually have this like intermediate data format. And we actually cared a lot about, before starting the project, we cared a lot about OpenTracing, and we decided, we actually surveyed, what is possible and how can we become OpenTracing compatible. But we realized a few things. The first thing is OpenTracing didn't allow correlation with other signals with distributed traces because OpenTracing leaves the trace context entirely to the implementer. So there's like no concrete type you can actually work against. Like there is like literally, it's all up to the implementer, and it's like such a compile time decision. And there was like no way to allow correlation with traces. Like it's so hard to write code where you correlate your logs with traces as well as your metrics with traces. The second thing is like we really cared about exporting to multiple backends because lots of our users actually have like, especially large companies, have this weird culture. They are exporting to multiple tools because a team is using one vendor, the other team likes the other tool. So you want to provide them some way to like export to multiple backends. And with OpenTracing, it's a little bit tough because everything is kind of like baked into the implementation. If you want to use a vendor, you link their implementation. But if you want to use two vendors, do you have to like link two implementations, and how is it going to work for propagation? There's all these like different questions. The other thing is we wanted to allow some more dynamic capabilities. Since OpenTracing is just a header file and implementation needs to be just like linked in, it's getting harder to do stuff dynamically because you have to actually put the right implementation in place before pushing stuff to production. By having this like intermediate implementation, actually OpenCensus was able to just enable exporting data. Just think about OpenCensus as an instrumentation library that does work, aggregates data or generates some data, but it doesn't export anything from the process if there's no sink around. And if there's one sink, it can actually discover that and it can start just exporting things. This is really critical because we realized that a lot of like frameworks or a lot of it's like out of platform type of projects are starting to integrate with OpenCensus. And the end user doesn't necessarily know about this, but there is some instrumentation over there. And if there's a production issue or whatever, we wanted to be able to, just turn on the switch and start exporting data, so you can actually see what is coming from the, the frameworks and the platforms as well. And the other thing was, allowing out-of-the-box instrumentation for binaries. Just imagine, like, Nginx, for example, want to provide some distributed traces. With OpenTracing, it's a little bit harder because for every vendor, you need to recompile Nginx, or you need to invent your own, this like intermediate data format to export data in a way so you can convert it to something else. We couldn't really go to like this like type of project to say that, hey, use this library and instrument it, and we're going to, maybe run this agent and be able to, just collect the data coming from your binaries. And it was a big limitation. And we just wanted to make it actually easier for vendors to provide support. If the model is just providing an API, it's getting a little bit complicated because re-implementing the entire implementation and again is just hard. So, and it's somewhat error prone. So we wanted to just make it as, we wanted to provide the instrumentation implementation, and we just wanted vendors to care about their specific bit, like converting our data format to their data format. On the other hand, like, I think it's just good to recognize that, like, both projects are widely adopted. Both have, like, a number of contributors. I don't care much about the stars on GitHub, but they both have some stars. There's like lots of companies actually collaborating on both projects. Google and like Microsoft and Omnitron has been really, big contributors to OpenCensus, and it's been there like, since the first 6 months or something. At least my experience there was good in terms of collaboration. And we can say that like, hey, choice might be good because there is these two projects maybe with different concerns. So maybe let's keep it that way, and why not? But the problem kind of like became like there are two actually main problems. So people were first looking for a winner because people need like defaults to go, right? So and it became such an issue because, hey, we're just kind of tired of like writing integrations, both for OpenTracing and OpenCensus, and we want to just tell people that like, hey, this is the way to go, and like we just want to support one way or the other. So it created a lot of like duplication of work, and also it was kind of like confusing for some people that there's like this like several issues on like major projects like this Hadoop issue. They're like passionately talking about pros and cons between these two projects. And it's actually funny because, they're trying to achieve the same goal. They're somewhat similar. There are few nuances, and there's all this work going on again and again at every discussion that, hey, what are the pros and cons between these two projects, and, which one should we go for? So we think that, like, hey, yeah, maybe it makes sense to have choice, but that's not really productive for lots of people. And some people have been like complaining to me that there was so much popcorn like in this issue, like there's so much conflict. And I said that like, yeah, I mean, if you've never needed popcorn, you've never been in this industry long enough. So I think that's normal, and I think there's a German word for that. So it's Technologie, Industrie, unerfahren heißt Popcorn Desinteresse. And since there's a German word for it, I think it's legit. And, and the actual, the other, I think the big elephant in the room, like the bringing back to this like other issue, we are already talking about like having like two different standard type of projects, right? What is going to happen, because we're about to maybe invent a third one. So that like, once you have 14, you always need the 15th, because there's no other way to go. Like, you can't really easily tell. These are both really successful projects with actual users. So we can't really say that like, hey, we're just going to kill one of them right now and going to replace like every reference on the internet with another. So it's not that easy. We recently announced that we are merging these projects, but the merging meaning we are forking a new project. And it's not, and it's not a real fork actually. It's a project from very scratch. And the biggest challenge is this going to be the third standard. The project is called OpenTelemetry. I know it sounds like 90s open source projects. I personally had some concerns on this, but it kind of grew on me, I don't know. So to talk a little bit about the scope, it's I think more closer to OpenCensus. There are two dimensions, first of all, the verticals and the layers. The verticals is where we think about different signal types. We have tracing metrics, logs probably, and maybe events. And on the layer side, we think about the core components. We will have some APIs again, some actual instrumentation, like the canonical instrumentation, but you will be able to override that instrumentation implementation. So if you need flexibility, you will be able to achieve that. We have some data collection pipeline components. This is where we have agents, collectors, maybe put in some of these collectors into the sidecars, and etc. And then there's some interop and data exchange formats. We've been also working on this W3C trace context with so many vendors in the last 2 years. And there's finally going to be a canonical header for distributed tracing. So it's really nice. It just really simplifies a few things. We will be able to understand each other's trace context. And again, I said we just want to have some canonical exchange data formats. This, just imagine any binary is outputting you some trace data, and you can take it, and it's compatible with OpenTelemetry. So you can just basically either use OpenTelemetry tools, or you can write your own visualization tool, whatever, to kind of utilize the data coming out of it. And this project is also going to have more of a bigger data pipeline infrastructure. So this is the core cases that we've been thinking about. There is a library component, which is going to be the instrumentation library. You can either just instrument your service with the library and directly export it to a backend like Jaeger or Prometheus or whatever. Or the library will be able to write to a collector, which is something that we're thinking about. Could be more of a cluster-wide type of thing. It's kind of like a central thing. You just collect things over there, and then you can optionally export it to actual backends. Or we're kind of thinking about utilizing the existing instrumentation. So we have this agent component where we will be able to understand the existing exchange formats. So if there's any instrumentation around, if you're running agent, we will be able to collect that and just kind of push everything to the collector and doing all this data exchange. And these are the boring parts, but we wanna we wanna support these 3 cases. So we have some short-term goals in 2019. I'm not working on this project anymore, so I am saying they care about backwards compatibility a lot. So this is going to be painful because we need to keep these 2 projects, OpenCensus and OpenTracing, for a while around because they're active users. And around September, there's some work going on right now, especially for the API design. And if you really want to want to contribute, I think this is the right time. And if you have any feedback in terms of APIs, I think this is the right time because in September 2019, I think we will finalize the APIs at least, and we will make a first, launch. And November 2019, if everything goes well, it will be the announcement for sunsetting the existing projects. So the strategy here is maybe replacing the existing implementation of OpenCensus with OpenTelemetry. We will keep the APIs, the public APIs the same, but it's going to use maybe OpenTelemetry underneath. And we will have this 2-year compatibility guarantee. The slide says read-only, but in terms of bug fixes, security fixes, I think there will be major fixes coming in this 2-year period. And then The long-term goal is actually more interesting because we just want to end up having one project. That's why we are, as soon as we are confident, we are stopping all the development on the existing projects, and we want to finally focus on this like large surface area and like correlation between these different signals. We want to work more on the data pipeline type of projects that I've been talking about. And I think it's interesting because if there's one canonical format for any of these signals, it will be so much easier for like the community to build tools around it. And I think 2020 will be the year to kind of like start thinking about those projects. And one of the other things is OpenCensus was this like big library. We are looking ways to make things more loosely coupled. And OpenTelemetry is now a part of CNCF, so there is like the IP is owned by CNCF, and there is more representation. And just kind of like to recap, OpenTelemetry will offer again some APIs, some instrumentation APIs you can instrument against, and some canonical implementations, and these are going to be centrally maintained libraries provided in the standard distribution, but it will be possible to tweak them. Like if you have really specific, for example, performance issues, you will be able to just rewrite the implementation. And then we will have some data collection type of components such as agent. And the goal is to have like as many integrations possible, and we want to keep the backwards compatibility with OpenCensus and OpenTracing for a while. And I think as soon as right after like November, we will be able to start having more conversations around putting this stuff into the frameworks rather than like just providing integrations. I just want to say that this is all I have. Thanks so much for having me here. I'm here the entire day, I can have questions right now. I really wanted to show you some stuff, but the API is really in a draft stage. Any questions would be welcome. And if you don't want to ask any questions, you can also email me. Thanks. Any questions? Great. Thank you.